Our speaker this evening is Ryan Smith. I'm going to say a few things about him, and then he'll say a lot, he'll fill in more of those details. So Ryan's a Senior DevOps Engineer at Veritone. He also works as an open source developer, and he's got a graduate degree in computer engineering from UCI. And he's done a lot of other things. He's a very experienced data scientist, more about that. And that's the end of my spiel. I'll bring Ryan up here and tell us all about Docker. Let's welcome Ryan.
Hi. Hello.
Welcome, Ryan.
Thank you. Hi, everyone. How are you guys doing today? Tonight. But you guys had a long day of work today. Like me. We will have the slide. There we are. Okay, so let me start. Quick time to record this bad boy, and we'll be on our way. Okay, so Docker, approaching the holy grail for software distribution pipelines. It's a mouthful. Gonna go over a lot of stuff. So who am I? What is a software distribution pipeline? Like, why do I care about that? And then I'm going to talk about technologies that support that. Docker, Docker Compose, Kubernetes, other orchestrators. Summary and open up QA. I do have some cool ending notes too. So about me, I'm Date Mike. Nice to meet me. Just kidding. This is from The Office. Testing out the comment. Anyways, this is me. So yeah, from UCI. This is actually Cal IT 2. I spent a few years at Cal IT 2 in this office right here. This is eHealth. So this is computer engineering and electrical engineering. So that was a lot of fun there. Companies. So I come from a lot of startups and small software shops. So about half of these companies have failed, and I've learned a lot of lessons from them. So this is why this is going to be fun. Okay, so GitHub. I love GitHub. I contribute a lot. Find me on GitHub. Okay, software distribution pipelines. So not only am I going to talk about technology, but I'm going to talk about business and why this is an important topic in business if you're a small startup or if you're IBM. This is actually very important. So as an engineer, it really helps to understand this. So just some definitions. Software distribution, the process of delivering software to the end user. Software distribution pipeline, the process is supporting software distribution. So what does that look like? Or why is this important? Why does this even matter? So Mark Andreessen, eccentric billionaire investor, points out that successful tech companies become distribution-centric rather than product-centric. And you could see these giant companies like IBM, Microsoft, Cisco, many others. So what he's trying to say is, as a company, as a startup, you have this great idea for this product. And some companies like to focus so much on this product, they try to make it perfect before they get it out the door, before it gets vetted with clients or anything. And for some of those companies I've been with, that's what killed them. They never released. So they burned all their money. So really, the takeaway is, hey, just get your dang product out there, get it out as fast as you can. So what is a software distribution pipeline? There's a lot of definitions, and this is kind of the way that I'm looking at it. This is the pipeline. So going from ideation to the people that create it, to the code itself, the code that turns to software, the software that turns to deployed software, and then the end users, and it creates a cycle. So they define the product that you need. So as you go throughout each level, the ideation, there's C-level, there's engineers, there's product management, designers, architects. There's a lot of people that, when you say, I have an idea for a product, there's a lot of people that come together. The developers are the engineers, and then engineers are in sprints. Engineers use IDEs, they use other tools, source control, GitHub. So the developers make the code, and then to turn the code to software, there's tests, compilers, security scan, bug fixes, documentation, feedback loops. I mean, there's a lot going on. software to deployed software. Hopefully, before you deploy software, you run tests. Test and prod, hey! So yeah, integration tests, user acceptance tests. You have pipelines. There's ways to manage secrets and configuration. And then when it goes to the end users, you actually have to have some end users. So then there's a ton of advertising, marketing, SEO. And once it's deployed, you actually have to make sure it's reliable, that you have certain SLAs and disaster recovery, things like that. So what are the goals of a software development pipeline? I mean, seriously, get it working end to end. I mean, from ideation to a product. I don't care if it's hello world, just get it working so that now you have a workflow, now it's just iterations on the workflow. Yeah, prove the pipeline. Minimize the number of cooks in the kitchen. Oh my God. There's just been so many meetings where there's too many people in the room and anyways, minimize the number of cooks in the kitchen. Except the product will never be perfect. It just has to provide value. Who here has used Craigslist? Everybody. Who here thinks Craigslist is a beautiful website? Nobody. Who here uses Craigslist? Everyone. Okay, so that's what I'm saying. It provides value. Just get it out the door. And create abstractions. Now that I'm talking to techie people, you will understand what I mean by create abstractions. Docker will help us create these abstractions. So let's talk about abstractions. Circuits. Abstracted away the physics of electrons and condensed matter. With circuits, you don't talk about equations. No, you just draw a circuit diagram. Hardware, abstracted away circuits and their components. Hey, now I have this box, I have this computer. You don't really care what's in it. You know, there's circuitry in it, but hey, as long as the hardware performs. Operating systems, abstracted away hardware. Hey, I'm running Ubuntu. All right, cool. What's the hardware? Don't care. Docker abstracts away operating systems. With Docker, you don't care if it's Windows, you don't care if it's Linux, BSD, whatever. You don't care. OS X, doesn't matter. With this abstraction, it helps your software development pipeline. It helps you be more flexible. So what is Docker? This is a nice little picture from the Docker website. Little side note, I actually messaged the chief marketing officer of Docker, and I said, hey, I'm talking about Docker. He said, yeah, great, I approve. So I got approval from them. They gave me approval. Okay, so Docker. Is just reiterating what I'm saying is that you can run it anywhere, cloud, virtual, physical, any operating system. Docker sits in between, and you can put any app, cool little Hadoop, Redis, anything you want. And this really is true. From a developer perspective, it helps developers and it helps ops. It helps iterations. I was talking to some gentlemen here, and they're talking about baking their VMs, baking their AMIs, and I said, how long does that take you to test that? An hour per iteration? Ugh, painful. Docker, it's like maybe 2 minutes per iteration. Oh, this code doesn't work? Psh, retest, rebuild. Docker doesn't work? Psh, retest. So this expedites everything. Why is this important? Jeff Bezos, $1 trillion company, Amazon. So stubborn in vision, flexible in approach. You need wiggle room. You got to keep the bigger picture in mind. But the idea is flexible in approach. Because what ends up happening with, I've been in a few startups and it's like, hey, we want to deploy to the cloud. And then a few months go by and they say, oh my gosh, bank regulations. We can't go in the cloud. We have to move to on-prem. So we have to move to on-prem. Oh no, hopefully our architecture from the cloud lets us move to on-prem with ease. I'll talk more about architecture and cloud lock-in later. Yes, yes. Flexibility. Business requirements are going to fluctuate. So just, hey, you're an engineer, figure it out, no big deal. You can do it. With abstractions in the proper places, it's about interfaces, right? So if you have an API layer that guarantees these certain APIs are going to be available, it doesn't really matter what's happening underneath as long as you're satisfying the interface. So now you can have different teams, work together as long as that interface layer is satisfied. So abstractions are important. Again, with Docker, write your code once, feel comfortable to deploy anywhere. It's similar to the Java saying, build once, or run everywhere, right? Yeah, I probably butchered that, sorry. Sorry, Java. Okay, so how do I get started? Just go to docker.com, get started. You can go to this website to play with it. You just Google playing with Docker. Just play with it. I mean, I've talked to a few people tonight that's like, oh, I'm kind of poking at Docker. Well, stop poking at it, start playing with it. That's the best way to learn. Fail, fail, fail until you figure it out. So I'm actually going to buzz through these demos. If I have time, I'll go back to them. But Docker is really easy to use. Docker is a command line tool. So what Docker offers are these beautiful pre-baked Docker images, similar to repos in Ubuntu, repos in Linux, So it's like, hey, somebody built this hello world container, this hello world image, and I'm going to run it. Docker run hello world. And it's going to output hello world, everything works. That was easy. Now you can get a little fancier. Instead of just hello world, you can have an echo server. And this echo server will say hello world and be available on port 5678. Docker run, you could hit it, now it works. And what's nice about this is just an echo server, but if you want to run Redis, Docker run Redis. So now you have Redis. If you want to run Postgres, or MySQL or whatever, Docker run MySQL. And now it's just running. You don't have to worry about installing. How do I figure out how to install MySQL on RHEL 7? You don't have to worry about that. Just Docker run, and it's up and running. So those are if you use pre-baked Docker images. If you want to build your own Docker file, if you have some custom app, so for me, I wrote some Golang code. That's a hello world server. I'm going to build it, and I'm going to use this Docker file to define what will my Docker image look like. So I'm going to copy the hello world binary into the root directory, Docker build, and then I'm going to Docker run. Hello world available on 8080. So within a grand total of 6 lines of code, I mean, you're up and running. My point is, I'm trying to say is, it's easy. It's easy. You can do it. Anyone can do it. Okay, Docker. So Docker helps teams across the board develop, manage, deploy their applications. Docker everything. Yeah, maybe, possibly. Databases. Do you want to Docker databases? We could discuss that later. But in most cases, if it's immutable, if it's not storing data, yeah, just Dockerize it. It'll make everyone's life easier. Docker Compose. What is Docker Compose? So what you saw earlier was a few CLI commands. If you wanted to run MySQL, Postgres, Redis, and your 5 servers, you would have to write quite a bit of bash. You'd have all these commands. So what Docker Compose offers is an easier way to put everything together. It defines everything in a YAML file, so it says, hey, I want these 5 servers on these ports with these specific environment variables. Docker Compose itself is just Python code. It's just a wrapper around Docker, but it's all defined through a YAML file that I'll show you next. Or why is this important? So it's easy for developers to write, share, and test Docker systems. This is Prototype Man from Mega Man. So it's all about prototypes. So what happens a lot with the companies that I'm at is, so there'll be a developer working on their server, and they'll make their Docker image, and they say, oh, I can't test it. I have to deploy to prod. No, I have to deploy to dev, and that deployment to dev cycle takes 30 minutes. Darn, But no. Use Docker Compose. Define everything, define your database, define all the dependencies, and then you can test everything locally on your machine. So what this looks like is, if I do want to run two services, two servers, here's one of my servers, here's another one of my servers. I'm going to expose it on this port and this port. So now, within 10 lines of code, 10 lines of configuration, you could start deploying everything. And what's great is, especially in the open source community, is these Docker Compose files get shared everywhere on GitHub. So it's like, if I want to start looking at Salt Stack, I could just Google, hey, Salt Stack Docker Compose file, and then I could see, oh, so this is how you configure master, slave, things like that, Hadoop cluster, TensorFlow, whatever, TensorFlow, Docker Compose. And you have a pretty good example. And then from there, you could hand it off to the ops team, and then they'll have a good idea of, oh, these are the ports I need to expose in the environment variables. So Docker Compose is really easy. You just say Docker Compose up, everything comes up. Only catch is it runs locally. So it's not a production thing. Like, you can't run everything because it's locally, right? And it'd be a bad architecture to say, oh, I'm going to do one giant virtual machine and run everything. Like, no, please don't do that. That's single point of failure. So the question is, okay, if I actually want a production system, how should I deploy a production system? Kubernetes. What is Kubernetes? Okay, Kubernetes. Production grade container orchestration. It's funny, on their website they say, deploy applications at planet scale. Not just internet scale, planet scale. So what Kubernetes does is manages Docker containers across multiple VMs. And you could cluster multiple VMs together. So if you have 100 containers across 10 VMs, Kubernetes will orchestrate everything and make sure all the Docker containers stay alive and that they could talk to each other. Kubernetes also offers something pretty cool where you can have multiple clusters, cluster in the East Coast, cluster in the West Coast, cluster in Mumbai, and you could federate them all together. So you could see all of them, and you could send work to specific regions. Where did Kubernetes come from? It was birthed from Google. Third iteration, they actually have a white paper on it, Borg, Omega, and Kubernetes. So it's actually pretty comforting to hear that like this is a third iteration, that they have learned from things before. Like, so one of the things, it's like a little minute thing, but like one thing they've learned from the previous iterations was, hey, for each container, we used to keep it in one CIDR block, but just change the port. So it would have one IP address on all the containers, but just different ports. And maybe that was Borg, and they realized, oh, that sucks. So what they do with Kubernetes is each container has a unique IP address. So then you can put any port on that. I mean, just a really minute thing, but it's good. They learned from it. Who uses Kubernetes? A lot of people use Kubernetes. Hardly anyone. A lot of people use Kubernetes. And these are just people that they know of. So I'm sure a ton more people are using it. Pokemon Go. Okay, so I'm bringing up Pokemon Go because I lived through that so long ago. No, but first of all, I love Pokemon Go. So Pokemon Go is run on Kubernetes. So they have this launch target. They're like, hey, we're gonna run Pokemon Go. This is 1x. And you know, estimated worst case, we think worst case, it can only be 5 times worse. Only 5 times worse. But then actual traffic, they start seeing it explode out of the gates. So they actually have 50 times the actual traffic. OMG. OMG. But after time, you know, they figured out all their little kinks. But Kubernetes was handling it all. And Pokemon Go was viral. It was amazing. Kubernetes system. Probably the ugliest diagram you see, but this just goes to what I was talking about earlier. So you could have multiple clusters, different regions, London, Mumbai, West Coast, East Coast, and you could federate. You could put everything together. Previously it was called Ubernetes, but now it's just, they've merged it in, federated cluster. So This is actually really cool and really nice, and I'll mention a use case of this at the end. But so one use case where you see that this is actually really cool is companies will have like a core, their core system, all the core logic, all the core just processing done in just one region in one AWS section, but they'll have edge processing all over in different locations. I mean, you see this a lot in IoT. And what this says is, hey, yeah, have your core Kubernetes cluster in your main region, and then for all the edge processing, yeah, put a Kubernetes cluster at each of them, and then you could send work off to each location, or vice versa. Pretty awesome. So running Kubernetes in the cloud. All the major cloud providers offer a hosted solution to where you just say, hey, I want Kubernetes with five nodes, bink, and then within like 5 minutes you have your cluster. So I don't want to like upsell clouds too much, but think about the numbers for a second. Understand that like with the cloud managing your infrastructure, you don't need all of like the sysops, all the engineers, all the hundreds of thousands of dollars of HR people or engineers to like manage the infrastructure. So it's pretty dang nice, and you get crazy SLA, crazy uptime. I mean, just so when you can, please use cloud services. And again, I'll talk about lock-in later. Running Kubernetes locally. So if you want to run Kubernetes, Docker brought it in recently. So when you upgrade Docker on your Windows or Mac, Linux, Kubernetes just comes pre-built in. So right away you could start using Kubernetes. Just install Docker. So Kubernetes configuration. It's a little bit more sparse than what you've seen for Docker Compose. This is kind of needed, so it's kind of a different structure. Like the way they do things is they have different, okay, so Kubernetes, you go to kubernetes.com/concepts, and it'll talk about what's a deployment, what's a replica set, what's a stateful set, what's a job, what's a service. It'll talk about all these things. And each one of those concepts, each one of those ideas is an independent entity. So what you end up having to do is, you know, for those people that use databases, you know, private key primary key, foreign key relationship between like deployments and nodes and services. So it all just comes down to selectors and matching labels. So across all of this, you'll see the selector is going to match labels on test echo, test echo, test echo. So what this is going to do is it's going to put a load balancer, and it's going to put it available at port 9999. It's going to run a container, and it's just going to do the hello world. And it's going to deploy it with a replica of 2. So it's going to make sure that always 2 replicas of this container is always running. And Kubernetes does have a lot of components inside. It has schedulers and other containers and stuff that make sure that these stay alive, just constantly running health checks. So it's like, it's a full-blown system. Demo is pretty straightforward. Again, it's just kubectl apply, and I'm going to apply this YAML file. So after I go through these slides, I can go through some of these demos also. So Helm, okay. I'm upselling Kubernetes, so what is Helm? Okay, package manager for Kubernetes. Okay, so why am I talking about this? How does a package manager for Kubernetes make sense? So, package managers. So if you think operating systems, Linux and stuff like that, like, you know, apt install Ansible. So now, instead of using apt, you're going to use Helm, and Helm is going to install the Kubernetes. So Helm install TensorFlow and Jupyter Notebook. So just with this command, it's going to take the working repo and it's going to deploy Jupyter Notebook and TensorFlow. I mean, they have all sorts of repositories for like Postgres, MySQL, Redis, all sorts of things, you know, Suite CRM. If you want to run a CRM in Kubernetes, great. Helm install, easy. And that's if you want to use a pre-built one. If you want to create your own, My friends at Cloud Posse created Monochart, and I just changed a few things, but shout out to Cloud Posse. But this Monochart just makes it really easy, So what I showed you earlier for Kubernetes was maybe 30 lines of, configuration. Now that could be boiled down to just 8 lines of configuration. And it'll do the same stuff. It'll have a deployment with the service, and it'll keep this up with the replica of one. And this is just way clean and way easy. The nice thing also, Helm, Kubernetes does it also, but once you start talking about DevOps and CI/CD, continuous integration, continuous deployment, you have to start thinking about uptime for your customers. So you have to think about, rolling deployments or blue-green deployments. So what's nice is when you deploy with Helm, you could deploy. If the deployment failed or there's bugs, you can roll back to the previous deployment. It doesn't sound all too fascinating, but when you're actually working with this day in, day out, just that should make you feel really happy to hear that. Okay, so Kubernetes. Extremely popular, battle tested. Magati. Yeah, so Kubernetes, it's hot right now. So I showed you the cloud page where it's AWS, Azure, and Google have their offerings. But if you Google cloud-hosted Kubernetes, all sorts of companies are coming out of the woodworks for hosted Kubernetes. I mean, companies you've heard of like Oracle and companies you haven't heard of that are, I don't know, based in Pasadena or something like that. A ton of them. Kubernetes. So there are other orchestrators out there, and I'm going to highlight them. I'm going to talk about them because they are valuable. Because I'm talking about software distribution pipelines, because I'm talking about get the product out as fast as you can. And there's more limitations than just, hey, I want the best tech. There's people, there's engineers, right? So you have to use a product, you have to use technology that your engineers actually understand. So if you want to deploy Docker in a distributed fashion in production, there are other orchestrators. Docker Swarm. Distributed Docker container orchestration built by the Docker team. Again, it's pretty much it's a very similar setup. I mean, you have manager nodes, you have worker nodes, and they make sure containers are always running and things like that. Internal state store, it's pretty much the same setup. There's a scheduler, you make sure your resources aren't over-provisioned, things like that. Docker Swarm. It's pretty easy to use. It's a small learning curve. It does have enterprise support. I really don't see cloud offerings, though. I mean, there might be, but maybe I didn't do too good of a job of looking. But cloud managed offerings. So again, when possible, please use a cloud managed offering of any service. And also, you don't see many articles or blogs or videos about massive deployments. I showed you Kubernetes with Pokemon Go, massive. Google uses Kubernetes internally, massive. Docker Swarm, I mean, again, maybe I didn't Google good enough, but you don't see that many things about it. And I think there are upper limits on how many nodes you can have in a cluster. But because of this ease of use, easy to use, sometimes you could really pound out a product really fast, within a month. Hey, we need an orchestrator deployed on-prem in a highly regulated environment, completely blacked out for your AI system. Hey, Docker Swarm actually worked. It worked pretty good. Speaking from experience. Quid. Nomad. I love Nomad. Oh my God. Nomad is amazing. Okay, so another distributed orchestrator. Same idea. You have leaders, followers. Just to point out, master and slave is kind of getting deprecated, so now it's leaders and followers. Anyways, so you have leaders and followers, and then you have clients. You could have them in different data centers. Everything talks RPC. Nomad is built by HashiCorp. HashiCorp has brilliant products like Packer and Terraform and Console and Vault. They have amazing stuff. I would love to do a talk on just HashiCorp stuff. Dear HashiCorp, please. Just kidding. Okay. Okay, so again, it's pretty much the same structure. So Nomad themselves published this 1,000,000 container challenge. I want to deploy literally 1,000,000 containers on 5,000 hosts, and it gets scheduled. All 1,000,000 get deployed within 5 minutes, and that satisfies all SLAs, all just all requirements. It's freaking amazing. Nomad has talks about some of their clients like Citadel. They're big in the money industry. Actually, I forget which industry, but big in the money. But they have big talks about that where they have huge processing farms. I think Spark, don't quote me, but they have huge processing farms, and they'll just do batch processing, and they'll expand out their Nomad cluster, do the processing, and then shrink it in when they don't need it. So, I mean, just, you hear great things. There's great evangelism around this. It's really easy to install. It's just really, it's honestly a single binary. You just put a single binary on all the hosts and put some configuration and you're up and running. Pretty easy to use, It can run more than just Docker images. Kubernetes and Docker Swarm only let you use Docker images, but Nomad, you could actually run just raw shell commands, raw bash. So if you want to, wanted to, upgrade all machines, you could say, oh, bash, 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 upgrade all machines. They have enterprise support. They have cluster federation. Again, if you want to go multiple data centers and glue them together. Cloud managed offering. Honestly, I don't use Nomad because of that, cloud managed offering. I don't want to spend time making sure things are up and running. Businesses don't want to spend money purchasing engineers' time to make sure things are up and running. So honestly, that's the only reason. If Nomad had a managed offering, I would push for that really hard. Okay, so summary. Software distribution pipelines. Circling back. Here's how Docker and Kubernetes fits into the software distribution pipeline between here and here. So when you take the code that sits in GitHub, so this is actually called CI when you automate code to software. So you have CI, take your code, whenever code gets pushed to GitHub, creates a Docker build, and it creates this Docker image. And that Docker image sits in a Docker repository. And then from here to here, when it gets built, continuous deployment pushes to your Kubernetes cluster. And then, I mean, there's things to think about again, like if you have clients and it's prod and you want 100% uptime, you gotta be careful with the rolling updates, blue-green deployments, and things like that. So recommendations. Dockerize all immutable servers. I don't see why you wouldn't want to do that. There's not a performance hit by using Docker. So the way Docker works on Linux is it creates C groups. So it's just isolating resources so that you can't go outside of the C group. So it's just all it's really doing is isolation. If you put it in an overlay network, if you put a virtualized volume on it, yeah, in those cases, there could be a performance hit with I/O in those cases. But really, Docker, there's not a performance hit. Use cloud-hosted Kubernetes. It's really easy to set up. Click, oh wow, I have a Kubernetes cluster. Use cloud-hosted databases. Click, I have Postgres now. Oh wow, Postgres is backed up nightly? Oh, it has 99.9999% uptime? Oh wow, I mean, you get encryption at rest, and I mean, you just get so many things that you don't have to pay engineers to do. Use automation. This should go without saying. If you're using Excel spreadsheets to manage your VMs, IP address to this VM on this host, I mean, no, please don't do that. Use Terraform. Use automation. Don't believe the fear of cloud lock-in. I think there's vendor lock-in, there's cloud lock-in. I think the problem is the vagueness around the word lock-in. So if you have your database in your data center, and it's Postgres, and you want to move to another data center, that's straightforward. Backup, restore. Okay, that's data center, data center. Now if you want to go to Azure to AWS, It should be the same thing, backup, restore. So I mean, what's the lock-in? Yeah, sure, maybe you have to pay to like move the data out, but it's usually marginal. So usually what I still hear is, oh, no, but it's going to be a lot of work to move from AWS to on-prem or AWS to Azure. But that's not because of lock-in, that's because you have a bad architecture. I'm sorry you architected poorly, but if you were running on Kubernetes inside AWS, then running in Kubernetes in Azure, the same dang thing. Same Docker images, same configuration, you just point to that cluster. If you want to move from AWS Kubernetes to on-prem Kubernetes, because you have a bunch of HIPAA requirements and things like that, Kubernetes, it's no big deal. Same Docker images, point over there. So, I mean, seriously, like, don't believe the hype, don't get into the fear of cloud lock-in. I mean, actually do some logical analysis, look at the numbers, look at the actual facts. If need be, try to move to a more regulated cloud. You know, I've talked to a few people and it's like, oh, I need FIPS compliant, I need HIPAA, I need all sorts of these regulations. Okay, great. So AWS has GovCloud, that already satisfies that. Azure has GovCloud, things like that. Beyond that, if you still need more regulated cloud, you can do a Google search for AWS C2S. And AWS C2S is like, I forget if it's FBI or something, like top secret level clearance for AWS. So you can Google that and it'll come up. So, I mean, the clouds have really great, they do a good job. Okay, worst case, fine. Worst case, fine. Move to on-prem, but use Kubernetes across the board, because then again, it's just pointing from cloud to your on-prem. I'm gonna jump a few slides, and I'm gonna go back to Q&A, but I'm gonna jump to a few slides. Chick-fil-A. Why am I talking about Chick-fil-A? I'm not that hungry, but they're yummy. Okay, so like I was talking about with the core, having a core processing Kubernetes and AWS, and then having all your edge processing, having all your IoT. Recently, Chick-fil-A had a post about how they use Kubernetes with their edge processing, and the joke that they were making is, hey, who has a bigger cloud? Azure, AWS, Google, or Chick-fil-A? Because in pretty much all of their restaurants, they actually have a Kubernetes cluster running. So they can actually, so they run their edge processing in the restaurant, and they push the data back to home. And this is actually a business model you hear a lot of, like, hey, I need my AI processing on the edge, push to core. So yeah, Kubernetes will enable that. And now talking about software distribution pipelines. This is kind of just for fun. I have a lot more screenshots. IBM Watson was spamming the heck out of me. I mean, for a company, please spend some time doing ads and marketing and SEO and things like that. Like, I really didn't care that much about Watson, but now that they just keep spamming me, I've actually started looking into it, so it's pretty cool. Okay. So I'll open it up to questions. Yeah, open it up to some questions, and then after that I could maybe do demos or see where it goes, or what do you think?
Let's give our speaker a round of applause. And we have this little token of appreciation, this certificate for you. Again, for a memory that you were here and you gave us that great presentation. We have a tradition that our first question goes to Windsor, and then we'll open it up to the floor.
Just by a show of hands, how many of you are IEEE members?
IEEE gives us money based on how many IEEE members show up in business.
Okay, that's
all right. Thank you. All right, and with that, we'll open the floor to questions for Ryan.
JO3.
Yeah, you mentioned one of the orchestrators that you wish had a cloud deployment.
Nomad. Yeah, Nomad.
Well, can you deploy that through Kubernetes? You said it's a single binary, right? Which actually Not on the other infrastructure
So,
and get the functionality.
so if you didn't hear the question, so I really like Nomad. So can you deploy Nomad on Kubernetes? I haven't thought about it. Truthfully, I wouldn't do it in a production environment, but for a thought experiment, just for some, just to test it out, like that would actually be pretty fun. That'd be fun to Dockerize Nomad and then run it everything. Yeah, it should be doable. Yeah, that'd be fun. Yeah. Yes.
So, how should we go about persistent storage in on-premises Kubernetes clusters?
Right.
Do you have experience of using persistent storage in an on-prem setting?
Yeah, so one of the companies we're at, they had Kubernetes on-prem, and so we didn't get too deep into it. And, well, actually, I think we're using OpenStack. So what it depends on is your hypervisor. So for on-prem, so are you using ESXi, are you using OpenStack? What? A lot of these hypervisors on-prem actually are now starting to adopt container persistent layer, and drivers for that. So truthfully, it depends on your hypervisor. Usually, if there's a plugin for it, it's usually pretty straightforward. It's just a line in the definition saying like, hey, use OpenStack as a persistent volume claim, as a persistent volume, and then that will, write directly to the hypervisor.
Thank you.
Yeah. Yes.
Thank you for the primer. One quick question, what presentation application are you using?
I'm using Reveal.js. Yeah. Oh yeah. So you can contact me via these. Other questions? Throw a softball at me.
Softball.
There you go.
Can't help but notice that your username is RMS 1000 watts. Now, is that RMS root mean square or Richard M. Stallman?
To bring up Stallman, you're a good person. You're a good person. So it is root mean squared, but again, it's also Ryan Matthew Smith. Yeah. Yeah. Question back.
So what are you guys using NetNet for orchestration?
For orchestration, so thinking in terms of software distribution pipelines, thinking in terms of getting a product out there, getting it vetted. Right now, we are using, with one of the companies I'm at, we're using Docker Swarm. We had really tight deadlines, and we knew Docker Swarm really well, and we said, hey, let's get this out there. Let's see if the client even likes what's running on top of it. If the client likes what's running on top of it and they want to scale, and we get a deal, yeah, we're going to move to Kubernetes right away so it can scale even a bit more. Yeah.
Do you have some examples of bad uses or bad ways to go about using Kubernetes, for examples?
Have you heard of Rancher? I know this is going on YouTube, but so we used Rancher plus Kubernetes in the past. Maybe it's gotten better now, but in the past, we had problems in regulated environments using Rancher plus Kubernetes. The problems were around just ports squatting on top of each other. Like Rancher needed some ports and Kubernetes needed some ports, but they were conflicting. And it's, yeah. So that's one thing. Bad use cases of Kubernetes. There's things.
Or how they went about it?
Yeah, really it's like lessons learned. So it's like, what lessons have you learned from Kubernetes? So, it's things around, I don't have a great answer. So it might be things around just performance-based, things that like, oh, I need to optimize later for, again, performance, things about that. So I don't have a great example now. Yeah.
Tools that you use to give you visibility into your instrumentation out there. So these containers are all living in the cloud, and ideally they're going to live forever. They don't always. You want to be able to see the metrics, what CPU you're using, what RAM you're using. What would you recommend for that?
So a popular tool right now, so there's a few answers to that. So if you want to see how the nodes are doing, you can use tools like Prometheus. Prometheus is just a great tool, and you can see how many nodes are deployed, what's the CPU memory across everything on clusters. Kubernetes itself offers a dashboard, so you can go on the Kubernetes dashboard. There's other tools, there's other just offerings like, what is it, New Relic, and I forget, we have a great one for database. Pardon?
Datadog?
Yeah, Datadog's another great one. So I mean, services like that get to see kind of what's happening on the application level. Because I mean, then there's questions like, okay, containers are up, and that's great for ops people, but now the CIO wants to know like, hey, how many 404s am I getting, and how long, what's the statistical average of like 200 requests? How long does a 200 take on average? So, and then tools like that, like Datadog, APMs, to just keep track of how long each request takes and things like that. So then that, yeah, so you usually need a combination of tools. And then again, you can push all logs into Elasticsearch, things of that nature. Yeah. So what brought you guys out tonight? Docker, Kubernetes, why are you guys here? I figure that'll open it up to more questions. Yes.
Yeah, also there's a GCP stack driver, a good solution. But I have a question like, what's the story behind in the intro it said data scientist / senior DevOps engineer. What's the story behind that?
Story behind that. So story behind that. So I got my bachelor's degree in physics. I got my master's degree in computer engineering. So I love math and science, and you can't do science without data, right? So the term data science is pretty funny because it's like if you have a degree in a hard science, you can do data science. So at the previous company, at one of our companies, shown there, they were doing white box machine learning. So at the end of the machine learning, instead of having a neural network that is hard to decipher, it was actually just an equation. It was symbolic regression, and that was used in the credit industry. So I actually had the opportunity to work with the data science team and on board with them and actually build out some of the code and just build out the data science workflows and data science itself of that engine. Yeah. Yeah.
You mentioned earlier about whether we should run databases on the cluster itself. So like you could do like a Helm install Postgres, but at the same time you could spin up a Postgres instance on GKE or AWS. Like, are there any like specific advantages using one over the other?
Yeah, okay, so the question is, do you run Postgres in Kubernetes or do you run Postgres on your cloud? So you should run it in the cloud because the cloud is going to optimize the database to perform in their cloud. Because what's going to happen is like, so all of these tools, Docker, Kubernetes, clouds, I mean, they provide abstractions and it makes it easy to deploy as a product. But I mean, you actually truly need to understand the OSI model and, you know, just understand what network layers there are. So if you're deploying on Kubernetes, the volume isn't going to be running on the same host. So then that's going to have to go through a NAS or a SAN or whatever network layers. So now you're starting to be throttled by network and all these other things before you even get to the disk. Yeah, so it's just a matter of understanding the system as a whole. Yeah.
Get out of here. Get a malfunction in your thing.
No, you can answer up here if you want. Yes.
Well, actually, kind of extending this previous question, do you think the serverless eventually will kill Kubernetes and Docker?
I love serverless. I could give a talk on serverless Lambda functions. I wrote a Terraform module that lets you deploy Lambda functions, but has all the state managed by Terraform. It's fantastic. Do I think it'll take over? Not yet, because of on-prem. And I mean, really because of just businesses in general. I mean, you start talking to CIOs and stuff, and then you say serverless, and then you're just getting them out in left field. So there's going to be quite a bit of adoption. So do I think eventually it'll take over? I hope so. I hope so. I mean, it's way easier to just write a function and deploy a function than it is to.
I think the economics is for the serverless, because for Docker, you pay for the container.
Right.
You pay for, Kubernetes cluster. For serverless, you just pay for milliseconds.
No CapEx, only OpEx.
Not just that.
Well, but I mean,
OpEx in milliseconds
Yeah, right,
versus
exactly. Very,
you're running
very
container
economical.
seconds, minutes, maybe hours.
I have two responses to that. As a tech person, you get it, great. But are the people writing the checks at the businesses, the CFOs that's going to approve this stuff, do they get it? That's one thing. So that goes back to software distribution pipelines. The other thing is, you said millisecond performance. I talked to a very seasoned SVP, and he actually had a problem with serverless to say that serverless goes through so many layers of authentication, abstraction, pushing here, pushing there, that, yeah, 10 milliseconds is great, but not fast enough. I want microsecond performance. So really it comes down to optimization, what your app needs to do. If you're just going to write a REST API layer for Uber or something like that, yeah, heck yeah, go serverless. 500 milliseconds is fine. But if you're going to write a crazy Kafka queue or something like that, that needs to just churn, hey, milliseconds is not okay. So it comes down to that also. Yeah.
How can you avoid cloud lock-in while using serverless?
Cloud login. So, again, depends on architecture. So, what does it mean to be locked in? It means that your function will be executed on this cloud. But if you write your Go code or your Python or your Node.js, if you write that sufficiently enough to be agnostic to a cloud, then hey, it doesn't matter. I mean, really what it would take is you write a shim, right? So you write some shim that's like, okay, execute this function if AWS, execute this function if GCP, execute this function. So there's ways around it, and there's ways to do it. So really it just, hey, just sit down, do some smart engineering, and we could figure it out. It's actually really fun. We should do that. Let me know. Oh, the other thing to point out, there's this open source for, so I hear a lot of serverless, there's this open FAS, functions as a service, and you could deploy open FAS on Kubernetes. And with that, hey, since you can run Kubernetes anywhere, now you could run your functions anywhere. So it's just abstraction on abstraction on abstraction. Yeah. Two questions. Okay, yeah. You had your hand first. Yeah.
In terms of adoption, many of the people here may be decision makers and maybe people who are not decision makers. What would you recommend to advocate getting this into your shops?
POCs. Hey, I got this up running in a week. Look, it works. It's solid. It's scalable. So what that takes is being lucky and finding that treasure chest on the internet that's like, hey, now I could deploy serverless within a week because I found this treasure chest of GitHub repos, or having a talented individual who has that treasure chest, right? So really, to influence decision makers, prove it to them. You know, hey, I got this done in a week, it's scalable, costs nothing. So, I don't know. I'm sure there's a ton of other ways to do it, but decision makers like to think about the bottom line, so. Yeah, question.
With that in mind, you mentioned the issues of business failure and success. Could you give us some feeling or insight of where there was success that could be attributed to the application?
Yes.
Or some where the failure occurred by not applying, or maybe you applied it by something else caused the failure?
Really, the failures that have occurred in some of these companies wasn't around technology. Usually we had the technology up and running. The failures usually happened because decision makers wouldn't let it out the door, or they would change their mind. Oh, it got out the door, but it's not right, we got to change it. So it never got to the vetting phase. Some of the companies that are successful, Veritone is successful, and they're just pumping out products, you know. So some of the decision makers that I talk to there, they say, hey, does it work? Can the clients use it? Great, deploy it. You know, if it's a little painful, okay, you know, we'll backlog the engineering work and we'll, you know, optimize and iterate and make it better, but hey, get it out the door. Just get it out there. So Usually technology is not usually the problem. Yeah.
Well, we've kind of reached our allotted time, so
Let me.
I'm sure we'll hang around here and we can network a little bit more. I think there's still a few cookies left and stuff like that. So one more time, let's give Ryan a round of applause.